Hello, in this video I'm going to be going through how to enlarge shapes where with a scale factor that is a fraction. So I'm going to do two examples of this, and I'm going to try and include in my explanation at least two different methods. So we'll see how we go. So the first question I'm going to look at is this one here, and we've been asked to enlarge this shape with a scale factor of 1/3 and a centre of enlargement 1/4. So the first step, as usual, is to put the centre of enlargement on. Be really careful doing this, don't rush it, because you'll be amazed how often people make little mistakes. So 1/4 is there. That's my centre of enlargement. You can label it C or X. I'm going to label it O, but it really doesn't matter what you go for. Okay. Now, to find the first vertex, I'm going to use the vectors method, which I discussed in a previous video. So let's work out where this point here ends up. I'm going to call it A. So first of all, I'm going to work out the vector to go from O to A. So that's how many across and how many up or down. So to go from O to A, I go 1, 2, 3, 4, 5, 6 across, and then 3 down. So I'm going to write that as the vector 6, 3. Now, in order to work out where A needs to end up, I have to take that vector and multiply it by the scale factor as if it were a scalar. So I'm going to do 1/3 times each of these numbers. And that's going to help me find the new position of A. So 6 times 1/3, or 1/3 of 6, is 2. And 3 times 1/3, or 1/3 of 3, is 1. You'll notice that both of those work out really nicely because both of these are multiples of 3, which is deliberate in making this question. So we've got O to A dash is 2. Sorry, I've forgotten to put a minus on. That should be a -3 because we're going down 3. So when we do 1/3 of -3, we get -1. Sorry about that. So we've got 2 across, 1 down. So if I go 2 across, 1 down from O, we always start from our centre of enlargement. 2 across, 1 down. That is my new A dash. Okay, I'm going to do one more using that method, and then for the next one we'll use the ray lines. So let's say I wanted to find out where this point here, B, ends up. So first of all, vector OB. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 across and 3 down. So I've got 12 minus 3. I'll get it right that time. So 3 downs minus 3. So to go from O to the new B, B dash, I need to divide all of these by 3. Okay, I'll find 1/3 of them. So I'm going to have 4 and -1. So I have to go 4 across and 1 down, again starting from my centre of enlargement. So 1, 2, 3, 4, and then 1 down. And that's new B. Now, depending on how confident you are with visualising these shapes, some of you, once you've done 2 points, will have enough to go on. We know that there is a line horizontally going straight from A to B, so we can draw that on. And if you think about the scale factor, you should find that the lengths have changed according to that scale factor. So this length here was originally a length of 6. As our scale factor is 1/3, the new length should be 1/3 of that. And 1/3 of 6 is 2, and we have got a length of 2. You can use that reasoning to do other sides as well. So I'm going to do one using that method. This was a length of 3. So 1/3 of 3 is 1. So up here, we're going 1 up. And on this side, again, it was a length of 3. 1/3 of 3 is 1. So we're going to go 1 up. For the last question, I'm going to draw a ray line on, so you've seen that method too. Okay, so I've drawn a ray line from O to this point here at the top. I'm going to call it C. So the other method you can use is draw that straight line and measure it. I've measured it to 1 decimal place, and I've got it around about 17.9, or just a bit less than 18. So because my scale factor is 1/3, I want to go 1/3 of that distance into that line. So you're going to be a little bit less than 6. Okay. You can still use the vector method. It's whichever one you find easier. I find that more and more students, as we get onto the more complicated questions, more and more people think it's worth going for the vectors instead of measuring and then doing multiplications or divisions. But when you do that, you should find that the point you end up at is here. Okay, so you can either do it by doing 1/3 of that length, or you can think of it as 9 across 3 up. So it becomes 3 across 1 up, however you prefer it. Okay, so we then end up with the final 2 lines on our shape, there and there. And if you think about the lengths, That was 3 diagonals, it becomes just a diagonal of 1. Okay, so we've got our shape. Obviously, if I were doing this on paper properly, I would be doing it with a pencil and a ruler, but I can't do that at the moment while I'm doing it up on this board. Right, next question. We've still got a fractional scale factor. This time we've got a scale factor of 1/2. Again, I'm going to put the centre of enlargement down first of all, 8,5. So 8,5 is going to be here. It's in the middle of the shape, but the principle works exactly the same as usual for this. So I'm going to do a vector first of all, and then we'll think about lengths. So I'm going to go for this point here as A, and I'm going to call my original centre of enlargement O, but again, you can go for any letter you want. So from O to get to A, I have to go 1, 2, 3, 4, 5, 6, but backwards and 2 down. When we're travelling that way, we give it a negative as well. Okay, so we're going 6 to the left, so it's a -6, and 2 down, so it's a -2. My scale factor is 1/2, so I'm going to be halving my vector. So to get from O to the new A point, A dash, I need to go -3, -1. So I'm halving the vector or dividing both numbers by 2. So if I go 1, 2, 3 back and 1 down, that is where the new point should be. And you should find on that straight line from O to A, it's exactly halfway along it. For the next point, I'm going to find it using the lengths. So this length along the bottom of the triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a length of 12. Now, when I'm doing scale factor of 1/2, the lengths are going to half. So instead of a length of 12, I should get a length of 6. 1, 2, 3, 4, 5, 6. And that should be the new point B. To check it, I'm going to draw a ray line from O to B, and I'm hopefully expecting my B dash to be halfway along that line. Okay, so I've drawn my ray line on, and you can see that B dash is exactly halfway along that line from O to B. The last one I'm going to do with vectors once more, just so you've seen one more example of using the vectors. So I'm going to call this C, and I have to go 1, 2 back, and then 1, 2, 3, 4 up. So from O to C, it's -2, 4. 2 that way, 4 up. So in order to go from O to C dash, I need to half that vector because my scale factor is 1/2. So it's -1, 2. So if I go back 1 and then 2 up, that is my new C dash point. So all I have to do now is join those points up. Okay, so that is my image there that I've drawn for you in blue. A couple of points to mention before we finish on this. So first of all, those methods will all work fine. So you can either start by thinking about vectors, and I would suggest you do that for at least one of the vertices. You can think about lengths and what will happen with the scale factor to the lengths. And you can also draw a ray line and then measure and halve or times by the scale factor, no matter what it is. So there's 3 different ways of doing it, and that's really nice because it also means you've got alternative ways of thinking about it to allow you to check your work and make sure you're happy with it before you move on.